Hello, everybody, and thank you for joining us today for Vertica Unify 2021. This breakout session is entitled Optimized Performance Everywhere. I'm Joy King, and I lead Vertica product and go-to-market strategy. I'll be your host for this breakout session. Joining me is the famed Chuck Baer, CTO at Vertica. But before we begin, I encourage you to submit questions during the virtual session. You don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after this session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send a notification as soon as it's ready. Now, please stick around to the end to get the code to gain points and participate in our Analyze to Win competition and win prizes. Now, let's get started. Over to you, Chuck.
Thanks for the introduction. Vertica's primary mission has always been to help customers use structured data. It sounds simple: get data in and out of the platform, provide lots of analytics and machine learning features to extract as much value from the data as possible, and do everything really quickly. It shouldn't matter what vertical the customer is in. They're all analytics-driven companies. Ideally, it wouldn't matter what the customer environment is, as data is generated everywhere, and as a result, customers are heavily committed to a wide variety of deployment scenarios. There are a number of other companies, products, and open source projects with visions that are very similar to ours, but there are big differences in approach. Some of the most hyped data management engines on the market today have reasonable performance, analytics feature sets, SQL ecosystem integration, and commercial support, but are lacking in one critical aspect. They lock you into the deployment platform, whereas we offer optimized performance everywhere. As you probably heard many times, Vertica got its technical inspiration from the collective wisdom of a group of academics and industry practitioners. If you'd like to hear more about this, please consider attending John and Jason's technical overview of Vertica architecture session. They knew that the Vertica should be a column store, and it should run on clusters of commodity pizza box machines, as they called them. Dr. Stonebraker once said, "In my 40 years of experience as a computer science professional in the DBMS field, I have yet to see a specialized hardware architecture, a so-called database machine, that wins." While Mike said this in 2011, he and the other professors certainly felt the same way back when Vertica was founded. Maybe back then they only said in the last 30 years, but they had certainly seen enough special purpose hardware fail to be sure of this point. It turns out that special purpose hardware is expensive to develop and tends only to optimize a small portion of the database architecture. This allows general purpose commodity technologies, which receive massively more investment, to catch up in performance quickly. And of course, commodity products are available at a lower price point due to the much larger production volumes. But the Vertica heritage has been an asset for a slightly different reason than the professors anticipated. We occasionally still hear about people studying special purpose hardware for databases, optimized disk controllers, networks, GPUs, FPGAs, etc. But what if you can't use those because of SSDs, object stores, the cloud, small footprint deployments, etc.? Put simply, if you don't need any special purpose hardware, you can run just about everywhere. So while we initially ran on-premise, predominantly on 2U rack mount servers, which were quite cost-effective and just as fast as anything else, today you'll hear about a much wider assortment of deployments, many of which are not possible with other products. To help all of our customers succeed, it's best to stick with a general-purpose software product. Where is everywhere? So if we run everywhere, where's everywhere? Obviously, we still run on racks of typical 2U rack mount servers connected with Ethernet. Lots of customers run their own data centers and do that. While it adds a bit to the cost profile, we also have customers that spruce up their enterprise deployments with virtualization technologies. virtual machines, storage area networks, and so on. Others have integrated Vertica into their data lake deployments. However, some of our on-premise customers have started taking advantage of the Eon architecture. This architecture uses shared storage, object storage like Pure or HDFS, for the primary copy of Vertica's data. Companies like Playtika, MassMutual, and MediAnalytics are using Eon on-premise to enhance their sizing, scaling, workload management, and reliability options. Some of them are here at this conference to tell their stories. Be sure to check it out. Of course, the Eon architecture was designed to run in the public cloud, where hardware provisioning is magically simple, and shared storage like S3 that's accessible from all nodes is the most attractive option. Vertica has been running in the public cloud, Amazon Web Services, for almost a decade, but in our traditional enterprise mode using EBS, Elastic Block Storage. These days, though, companies like the Trade Desk use hundreds of AWS nodes in Eon mode. With subclusters, they can start and stop on demand to match the needs of their workloads. Vertica also runs on GCP, the Google Cloud. MassMutual is here at the conference to share their story about voltage security, but they happen to use GCP. Finally, we have customers such as AT&T who are currently testing Vertica deployments in Microsoft Azure. Vertica's deployment flexibility doesn't just allow us to run in a lot of places. It also enables some flexibility in our business model. One thing you're certain to hear a lot about here at Unify is the Vertica Eon Accelerator, where we help you by managing your public cloud deployment of Vertica. Vertica Eon Accelerator is a bit different than other cloud databases you may have encountered. We're here to help you get going, but the deployment is in your cloud account. It belongs to you. And you can use your Vertica Eon Accelerator in conjunction with other Vertica deployments. Maybe an on-premise deployment run by another department, a test cluster in another public cloud, or even on a developer's laptop. If you're curious to know more about Vertica Eon Accelerator, check out Vishal and Sumit's talk, Introduction to Vertica Eon Accelerator Early Access, which will be presented tomorrow. Like all our talks, a recording will be available afterward in case you miss it. The fact that Vertica runs everywhere might not be that interesting to some of you who have very traditional or popular deployment scenarios with lots of competitive offerings to choose from. But Vertica has a group of customers, we often refer to them as OEMs, who want to embed Vertica into their analytics applications, package them, and in turn, sell them to their customers to deploy. Telco suppliers and network management software providers are particularly interested in this model. They might want to deploy analytics software for phone network operators that have given them a few units of rack space in each of thousands of mini data centers located in windowless brick buildings in cities around the world, each slightly different and each without an on-site Vertica DBA. Containerization, Docker, the Open Container Initiative, Kubernetes, offers a promising solution to this challenge. Setup and management operations can be scripted and then run at each site by the container orchestration platform. Here again, life can be tricky because each OEM customer may be using a different tech stack to accomplish different goals. So it's important to know that we offer them individualized help. We provide examples and documentation for those who want to do it themselves. They need to know about the Vertica command line, the steps you need to follow to organize nodes into a cluster, that sort of thing. But that isn't in our traditional documentation. We keep it in the Vertica Integrator's Guide. In some cases, there are reusable parts, images, Helm charts, Kubernetes operators, and so forth that are needed. And our goal is to provide reference implementations, but as open source software, so you can use them or make adjustments to suit your specific needs. If you want to learn more about using Vertica with Kubernetes, I suggest Ning's talk later today, running containerized Vertica with Kubernetes stateful sets. If you search the web, you can find examples of customers such as Good Data and how they've made use of Vertica using containers embedded in their own products and solutions. And I must say, good luck doing things like that with other popular cloud databases, whether offered by the cloud vendor or otherwise. As I keep saying, Vertica is just software, C++ code, so it ought to be able to run anywhere. You may have noticed that the ARM CPU architecture that is quite common in cell phones and network switches is making another run at the server space. We had a couple of product managers and developers who wondered how well Vertica would run on ARM. So we got a cloud instance, Amazon's R6G with the Graviton2 ARM processor, recompiled Vertica, and tried it out. We didn't spend much time tuning the ARM build, but the results are modestly promising. The initial ARM build on R6G is only about 3 to 10% slower than similar x86-based R5 instances, but 20% cheaper to run. And I probably should have put error bars on this chart. Some queries on ARM ran faster, others slower. Just putting forth an average is an oversimplification, but the proof of concept is there. If customers want to run on ARM, we can do that. In fact, you know how developers love to do things just because we can? It might seem a bit impractical, but Mark Wally, maybe some of you are lucky enough to work with him, did load that ARM port onto his Raspberry Pi, and it does run. I suppose, thinking back to the early days of Vertica 15 years ago, the Raspberry Pi, if you add a terabyte of SSD storage, stacks up quite well against the 4-core Dell PowerEdge servers we used back then. And people got commercial value from running Vertica on those, so who knows? But anyway, I think it certainly proves how embeddable Vertica can be and how we can run everywhere. So what are we doing to enhance performance? Now that I've shared a bit about all the places where Vertica currently runs, let's get into some details about how we're able to optimize performance in so many different environments. Performance techniques in Vertica fall into 3 main categories: what we call the execution engine that processes data row by row, and the query optimizer that devises a plan for executing the query. You can think of it sort of like a factory assembly line for query results. The query optimizer sets up the sequence of operations needed to calculate the answer, and the execution engine provides the algorithmic machinery for processing data at each stage. We also have a performance category for everything else, little bits of code, like the catalog and the control networking, that just do their jobs without ever being the bottleneck. Vertica has been built on a solid foundation for query processing that starts by organizing data for optimal retrieval. We keep the data sorted and compressed, separated by column, and divided across a cluster of machines. This is all done so that we only retrieve the data we need for a query and can perform that retrieval in parallel. Once data has been retrieved, that's when the interesting processing starts: sorting, grouping, joining, calculating expressions, running analytics windows, and so on. So when we look at optimizing performance, we need to look at how a wide variety of hardware can be used to approach the problems of data retrieval and query processing. The main hardware components are storage, memory, CPU, and networking, and these have changed a bit over the years. The original design point for Vertica was spinning magnetic disks, but now we run on object stores and SSDs, which tend to pull the optimal design point in opposite directions. We've gone from optimizing for raw memory to environments where hypervisors can insert significant overhead and access times. Processors have gotten a lot more cores since our original algorithms were developed, and we can no longer rely on a simple network topology. Let's start by taking a look at storage. When Vertica started, we ran on magnetic disks with ext3 file systems. 1 megabyte I/O size seemed like a reasonable choice. Slightly larger sizes were better for large transfers, but if you wanted something small, the access time was about the time that it took to retrieve a 1 megabyte chunk. So that was a good compromise. The file system automatically caches disk in and provides read-ahead on magnetic disks. In this design, 1 big file is better than a lot of little files. And the file systems support full set of operations: read, write, append, and update. And you don't have to handle any errors. If there's an error reading from a local disk, you're going to need to send a sysadmin eventually. Now we've added SSDs, S3, and HDFS. SSDs, of course, allow much smaller writes, where the cloud stores benefit from even bigger operations. These don't provide caching or read ahead, at least not the cloud stores. In cloud stores, very large files, counterintuitively, are much harder to work with. They don't support random access. They don't support random writes. They might support append if you're lucky. And in the cloud, error handling is so tough that you better be prepared to start your operation over again. So what did Vertica do to accommodate these things? We've basically kept our 1 megabyte I/O size on columns, and we use larger I/Os for temp operations so that they work on cloud stores. Today, we have a decompression cache that covers cloud stores just as well as it does local disks. In the future, we'll add a buffer pool, as I'll explain later. In the new design, instead of using one big file, we found that in our new algorithms, we can use multiple files for temp space. It works just as well on the local disks, and then we can retry operations and do the error handling we need in the cloud. And going back to our roots, our analytic transaction model turns out to have never used the full capabilities of a local file system. We never did updates in place or anything like that, so we were always good to go when it came to cloud stores. Moving on to memory, it has obviously continued to expand in a capacity at a nearly exponential pace and at increasing bandwidth. What has changed less is the access latency, which has not been reduced significantly. So other factors about the evolution of memory turn out to be more interesting. The overhead of virtualization should be considered, and if you use small memory page sizes, the process of setting up address space in the operating system is more expensive than the memory read-write cycle itself. And if you use large page sizes, you get a different set of performance artifacts, particularly for small queries. These factors have led us to a multi-year plan to change how Vertica manages memory. When we started the journey, we sort of looked at memory as a simple pie, with several components taking their allotted slices and making and freeing allocations as they pleased within that model. We have long-lived memory allocations for the catalog and other shared data structures, and short-lived allocations for user sessions and threads. Bigger, short-lived sections are used by running queries. Remaining memory is used to cache frequently used data. A cache of uncompressed data is managed by Vertica, and memory not used by the Vertica process is used by the operating system, likely to cache ROS data from local disks, or the depot, which caches ROS from shared storage. We're moving to a model where Vertica doesn't use the operating system to manage memory on an ongoing basis. We want to allocate the memory once and then recycle it. We also don't want to rely on the operating system to cache compressed data, because it can't do that in Eon mode for data that doesn't live in the depot. This turns out to be a somewhat common idea in relational database design. It's often referred to as a buffer pool. By managing memory ourselves, we can get consistent performance across all deployments. If you listened to my talk last year, I mentioned that CPU speeds really aren't increasing anymore, and that Vertica is updating its core algorithms to take advantage of modern compute resources for our 5th generation query execution engine, EE5. And you know that we've pretty much written off technologies like GPUs and FPGAs as niche. They aren't particularly applicable to general purpose databases, and they won't help our customers who expect to run under flexible deployment conditions. A lot of data processing algorithms use sort at their core. We sort all data before we store it to optimize retrieval. And once data sets get large, sorting is one of the best ways to group and join data. That's why we've designed a new sort with all the things I said about storage, memory, and CPU design kept in mind. Last year, I mentioned that it was competitive with world record holding 10-cent sort while being much more general purpose. And this year, I'm pleased to say that we've tuned it, and now it's about 10% faster. We're gradually integrating this new sort into our algorithms. This year, we're seeing that, as predicted, our new sort core can tremendously accelerate grouping operations, particularly in cases where our old algorithms didn't do as well as they could have, such as with string columns that were defined to be long but were generally short. You also see that as we're integrating EE5 algorithms, we've decided that it would be best to take more of the CPU scheduling function away from the operating system. Instead of using threads, our new algorithm issues tasks, which we can individually prioritize to meet the needs of the workload. Finally, with regard to networking, the throughput speeds have become faster, but we can't count on the availability of multicast, especially in the cloud. Networks have become much harder to control and diagnose. For a long time, Vertica has used a networking toolkit called Spread. It provides the cluster synchronization framework, but it performs best on multicast networks. To optimize performance everywhere, we're gradually replacing it with a new design, the transfer service. Maybe we need to work on a more exciting name for that. So we're offloading large payloads, such as big catalogs, off of Spread. Here you can see that the transfer service offers a remarkable improvement on cloud networks when compared to Spread, even when Vertica is optimally configured in its large cluster mode. We've of course checked and also found that the new transfer service is competitive in our traditional shared switch enterprise deployments. So now I've talked quite a bit about a lot of things that might seem separate, but it turns out they actually fit together into a cohesive new design for the Vertica core. If you combine our parallel sort algorithm, which is designed to use CPUs effectively, and use a memory access pattern that's compatible with a buffer pool design, and that buffer pool design is backed by cloud object storage, you get a solid design for storing intermediate data within a large query plan. And if you redistribute the intermediate data using the new transfer service, you've used all the pieces I mentioned. This is also somewhat traditional database design principle. Store intermediate results in a temp relation because maybe the user specified a with clause, but more likely because it makes sense within the context of a query. It's amusing to me to think back at why, in the early days of Vertica, engineers ignored the common wisdom of having temp relations. Honestly, we told ourselves that temp relations meant you'd just be writing the data down only to read it again, and that sounded like wasted overhead to us. Turns out, though, that over the years, we built temp relations. We already have temp relations. They're just informal. Every sort, grouping, and most joins essentially build temp relations, maybe in memory, but they will certainly flush them to disk if the data sets are large. So now we've learned, or maybe confirmed, that formalizing temp relations makes a lot of sense. If you decide you're not going to use temp relations, you might get a query that has a relatively large query plan, like this one. This is probably a medium large query plan. If you attempt to run it all at once, you see that each little station, each little box, maybe they're hard to see, but there's, because there's so many, they all need resources to run at the same time. Realistically, that's not the way it's going to run. As I mentioned, every time there's a sort or a grouping or a join, there's a good chance that the data is going to stop. The section of the plan that fed that is done, and then it's going to start reading from that and run the rest of the plan. So we should be able to break the query plan into parts when we run it on temp relation boundaries. Using the new EE5, we're able to do that. But we've proven that the idea makes sense using our existing query executor. We took a couple of queries, TPCDS queries, whose performance was not particularly inspiring to us, and we just try to see what would happen if we break them up into pieces. And we found that a piecewise multi-part plan is significantly faster, maybe as much as 10 times. Again, like I said, this is using our existing, sort of insert select design for temp tables. Using the EE5 temp relations, you would get the performance improvements of both. New temp relations will help us improve our handling of the with clause. Of course, a with clause is sort of a subquery specified by the user for use at multiple places within an outer query. Right now, we can do temp relations as temp tables for those, or we can inline the query at every point where it's used, but using temp relations will give us the best of both worlds there, maybe a little better. And then our new recursive with statement, which currently makes a relatively large query plan for each level of recursion, can use the temp relations and avoid having a recursion limit. Now I'd like to mention one more use of our new temp relations. Finally, after many years of customer requests, we've started adding stored procedures to our product. I don't want to get your hopes up that the first version of this is going to be a drop-in replacement, bug for bug, quirk for quirk compatible with PL SQL or T-SQL or whatever your favorite database stored procedure language is, but we have started with something very similar to PL PG-SQL from Postgres and other similar products. As we go along and build it, we're providing support for result set cursors, time-based actions, and triggers. But again, please do keep in mind the kind of operations that this stored procedure language is designed to do. It's designed for automating common database tasks and scheduling the tasks. It's designed for taking sequences of steps in an ETL process and formalizing them and recording that logic in the database. It's designed to do flow control and iterative algorithms such as machine learning or graph analytics. It's not designed to take each row in one large relation and go do a sort of software join where you query another relation sort of as a self-join. Those things are going to be pretty slow. And again, it's not designed to be a drop-in replacement for pick your favorite other commercial products, very vendor-specific language. Vertica believes that data sharing is important. While certain competitors make data sharing particularly easy, they can do this because they control and manage all of the data in one centralized deployment shared across all their customers. Our database runs on many sites and under a wide variety of scenarios, so in many cases we can't just flip a switch and give someone else access to your data. We have to ship data between deployments. Also, we don't want to lock you into one shared deployment of our database. We fundamentally believe in open data exchange and support for a wide variety of tools. The key way that Vertica enables you to share data in an open way between your own tools in your data lake or with colleagues or external organizations is, of course, by the way of open data formats, particularly Parquet. While you have to make some arrangements for the transport and security of your Parquet data, I think you'll find, as I have when I work with our customers, that Parquet import and export just works. We've supported Parquet, ORC, and a handful of other open formats for years now. We continue to invest heavily in this area. Hopefully you get a chance to listen to Deepak and Ryan's talk, a deep dive of complex data types, which covers our ongoing effort to support all the data structure flexibility that Parquet offers. Our recent support for complex types is an exciting complement to our traditional relational data model and more compatible and performant than our flex table offering in cases where the schema is known in advance. While Parquet is the backbone of high-performance parallel data exchange with external tools, we make special efforts to provide out-of-the-box integration in the most popular scenarios. Our new Spark connector is a prime example of this, with integrated security and predicate pushed down for cases where you don't want to export your entire data set. The Parquet data format, of course, is just a piece of the puzzle. You need to specify the storage endpoints and other resources that enable parallel data file transfer, and you should probably configure the security. So our connectors make it very simple to do things like that. Of course, while we always pledge support for data lakes and open ecosystems, our customers expect a variety of simple approaches for sharing data within Vertica, within an organization or between organizations. We've traditionally had two main approaches to this, a backup restore style of operation that moves Vertica ROS files around between tables with identical structure, and an import-export operation that can process and transform the data in flight as it moves between clusters, much like an insert-select statement that selects from one cluster and inserts into another. If you want to share live data and a single database isn't sufficient because you don't want the workload sharing the same hardware, for the last few years now, you've been able to use our Subclusters feature. This is a simple way to share data using Vertica's Eon architecture, multiple subclusters accessing data from the same shared storage. You can have a primary subcluster that is always available to handle loads, and then a variety of other subclusters for other uses, maybe dashboards or analytics, and you can size, start, and stop these secondary subclusters independently. If you want to learn more about subclusters, consider attending David and Alex's talk, Vertica in Eon Mode, Performance Improvements for Multi-Petabyte Scale. But if you want more isolation, perhaps to share data with an outside organization, or perhaps because the clusters should be available independently, you'd like more options than subclusters currently offer. You'd like completely independent clusters that share data without access to the same shared storage. Some simple way to transfer data between clusters efficiently in Vertica's native format. There are a variety of reasons why this isn't currently easy to do. Vertica subclusters coordinate using a network toolkit called Spread, and that doesn't work well across WANs. You certainly don't want two companies' IT departments trying to coordinate control of it, and I suppose you probably don't want to be offering access directly to your shared storage either. The firewalls for that would be hard to set up. It's probably becoming obvious to you that we need to be able to easily zap a copy of the data over to the other cluster for it to keep and manage in its own storage. That way, both clusters can access their own copies without concern for the availability of the other, much like an active-passive disaster recovery architecture. It would be great if this could be done incrementally, so that as the table changes, it is cheap to send and apply updates to the other cluster. And if you remember Vertica's model for keeping data in separate files, maintaining snapshots, forking tables, etc., you'll know that this ought to be possible. You might also be thinking that if you can send data one way, you ought to be able to send data the other way as well, and that it would be best if the transfer protocol was based on standards to the largest extent possible. We think that HTTPS fits the bill, that this is the easiest way to get through firewalls, and that you could use your own scripts and tools to perform the transfers if you chose to do so. So how would it work? First, you'd have a table download API. Using a standard HTTP request, using standard authentication headers, and formatting the request details in an open way, maybe JSON or similar, whichever is easiest for your tool, you'd request the table storage list. If it's an incremental transfer, compare that list of files to the list you already have. Then go straight to the compute nodes to download the files you need. Again, using HTTPS, you could use wget if you want. One nice thing to note here is that the compute nodes are abstracting away the storage architecture for you. This is how we'll make it simple to copy the data files between deployment approaches. Uploading a table is not going to be significantly different. The process involves working out which files the cluster needs to receive, and perhaps which files it has that are no longer relevant and should be dropped, and then sending the data, delta. If you can do these two operations using open protocols, you can move data between clusters. Of course, unless you're an OEM, you probably have no interest in doing it yourself, knowing the details of the protocol and the steps to use it. You just want to synchronize and share data between Vertica clusters, so that's what we'll build. In summary, a database that can run everywhere needs a variety of data sharing approaches for security and flexibility. Not just between users in an organization that share a database or between customers using the same product, but between a variety of organizations with different deployment methods using a broad ecosystem of data management tools. You want the data to be shared, maybe with a cluster in another cloud or data center. Maybe it's far away, maybe it belongs to another company, maybe it's on the other side of a firewall or three. We can't take the same approach as our competitors that lock your data and only run in one place, and we don't want to. Vertica's solid foundation based on pure software allows us to offer a value proposition that's unique in the market. Compared to any other commercially supported data management product, we offer unmatched reliability, scalability, and speed across the widest variety of deployment options. We offer full support for the SQL ecosystem of tools for loading data, generating reports, and visualizing the answers to your most critical questions. We build in advanced analytics, support all of your data, and enable machine learning deployments at scale. We can help you embed Vertica into your application and enable data sharing in an open manner. I hope that you're enjoying Unify, that you've checked out the stories of some of our many customers and heard about some of our new features. If you haven't, you might consider Mark's talk, What's New in Vertica, and I hope that you've generally learned a lot of new things from us at the conference. We'll be taking questions live right after this presentation in just a few minutes. If you need a lot of practical knowledge, want to brush up on basic Vertica topics or get a certification, I do recommend the Vertica Academy. Also, if you have detailed questions that you think only implementers might be able to answer, or want a little bit of advice on your own project or problem, don't forget to attend the developer lounges offered on each day of Unify. Or if you're watching a recording of this presentation, or think of questions a while from now, don't hesitate to bring them to the Vertica forums. Thank you.
Thank you all for listening to this presentation. Now, we're ready for Q&A. As always, well done, Chuck. It was a pleasure to hear from you. But we do have some questions coming from the audience. So, are you ready?
I'm ready.
Okay. So, here's a very fundamental question. What exactly does the separation of compute from storage really mean? Because isn't that fundamentally at odds with performance at scale?
I think it is at some level, at a technical level, fundamentally at odds. If you move the CPU far away from the data, processing is going to be slow, and there's a lot of approaches to that. I think the marketing side of separating compute and storage is a strong one, though. People want the flexibility of scaling compute and storage separately. They want to pay for it separately. They want to have different demands on one day than another, and it comes up to us as technologists to figure out how to bring the data and storage together efficiently, because they eventually have to meet. So, that's why we have things like the depot and our caches and things like that, and we do our best to bring them together dynamically and cache it there so that you get the performance you expect from us, even though at a marketing and deployment level, it behaves as if they're separate.
Well, I think you could argue that there's a lot of different ways to define performance, right? The best performance at the best cost might be considered the best performance. So maybe that's how we consider it.
Absolutely. The total cost of ownership, it has to be easy and flexible to deploy and not take a lot of human time, and it has to be cheap to run, and it has to return the query results quickly. And I think that's why people kind of want to have their cake and eat it too, and we do our best to put in the features you need to do both. Hopefully you
And speaking, wow, we have an absolute deluge of questions. This always happens when you talk, this is the story. Okay, now we're going straight into some more tactical questions that are heavily voted for. The next one is, Chuck, are recursive with statements a new feature? What version of Vertica are they supported in?
So recursive with is a new feature. There's a recent version of 10 that has our initial implementation of that. Pains me to say so as a developer, it's not the best version you'll ever get of our recursive with function. We're going to keep making it better. So you might see a very complicated query plan for your recursive with right now that limits the recursion depth to a number, but we're definitely improving that, and so at some point in version 11, you will see the improvements coming through. I'll take this because I sort of assumed the first question was going to be, what version is this stuff in generically? Take a moment to tell you a little bit about our development cycle for 11. That will come out shortly, but we're going to release service packs with new functionality in them every couple months as it sort of matures and we get the customer feedback. So that's a little different than what we've done in the past, but it will allow us to take a lot of the things that you've heard me talk about here today and put them in the product under an option to play with. A few things I talked about are already in there that you can play with. And then as we sort of make sure that they win on performance in all the customer cases, not just the ones we tried, we'll make them the default behaviors. and some of the things like the HTTPS service is a little farther out. So just generically, that's when you can expect to see this stuff.
Okay, and to clarify, so first there was a question about what are all the features in Vertica 11, and there's two ways to answer that. First, Mark Lyons will be hosting a session today that talks about what's new in Vertica 11, so you can listen to that. We issued a press release this morning at 9 a.m. East Coast time, which details a lot of the Vertica 11 features and capabilities. You can read there, and all of the documentation for Vertica 11 will be on vertica.com. In terms of when the code is ready to download, we expect that to be in the next 30 plus days. The engineers always like to over-deliver, and marketing is responsible for ensuring that we don't overpromise. So as soon as it's available, you will see that, but it will be very soon. So that I can guarantee. And now, back to the most voted question, Chuck. What will be the relation between buffer pools and resource pools?
So if you look at the pie chart sort of interpretation of memory, that's still going to be there between users. So that would, the resource pools control that. It's still going to say, gee, please don't let so many reports run that I can't do my loading or my interactive queries from my website. It'll still do that, and will control what's there. What the buffer pool does on top of that is it makes it so that we can cache stuff regardless of whether it was from S3 storage or local disks. It allows us to be able to repurpose memory without changing the address space, so it makes us much more efficient. It allows us to use S3 and object storage as temp better. So from a system level, the buffer pool allows us to implement what we wish the resource manager did in a much more efficient way than it does now. If we get in a pinch, we can just kick something out of the buffer pool to make room for a catalog or something like that that's more urgent. So that you can have the resource pools take effect more dynamically and things like that. So from a user perspective, it's still, resource pools as a user feature to define which workload gets prioritized and allowed to run and not clog up the system. And at the technical level, it's the buffer pool that makes it seem more magical than it does today.
Okay. Now, here's a question that I know is very close to your heart, and it also just ended up on the top of the list in terms of audience votes. Does EE5 sorting algorithm give better query performance in general? And what Vertica version is that supported in?
Right. So when you look at query performance, your query can spend its time in different places. The first place it usually starts is in selecting data from tables or projections. And what we've done to make that as efficient as possible, as you're probably well aware by now, is broken it up into columns and kept it sorted so that we can find just the data you need right away. And we just talked about the buffer pool, how we can keep the disk or the object store from being, the bottleneck if it's a very frequently used short query type of thing. Where the sorting will improve your query performance, it is going to depend on, sometime in the 11 timeline, you can experiment with it or use it. You could see queries that just have a sort in them. That's not that big, but we have some analytics queries that sort the data before they run the windows through the pipeline. We have grouping queries. Group by queries should be coming along somewhere in the 11 sequence. That's not really a sort, but it uses sorting as a fallback. Grouping and joins use sorting as fallbacks. And then, of course, when you load data at some point, you get into a situation where you sort the data for the projection. And if that happens to be the bottleneck, you'll see improvements from the sort there. So it plugs in at a variety of times. Don't want to under or over promise, as Joyce said.
Yes. Now here is another question, and this one is related much more to Eon mode, but also very specific to performance. What are the benefits of having the depot on or off?
Yeah, that came up with our customers yesterday. The
They
benefit
did.
of having the depot on is that if your shared storage is slower than local disk, which one would tend to assume because it's farther away and has more bottlenecks in it, then having a local copy of it, that's just standard caching. So it's the benefits you get from any caching. Uh, Vertica architecture, if you've been following it, we have a pretty easy job when it comes to implementing caches because of the way we don't do updates in place. We might have some files in the cache that are, not needed anymore, but we'll never get something that's stale or anything like that. So we got a pretty easy job to make cache coherency work. When would it be better to just use Depot? Well, or sorry, to skip Depot and just use the shared storage. I suppose if you had a one-time job, if you had a sort of just wanted to run something real quick, then you don't want to pay for the depot. The storage accesses are pretty good. Maybe your local disk is super slow or something like that. I suppose the depot on a thumb drive or something like that is going to lose to the shared storage. But those would be the reasons to not have depot. Either it's just not feasible in that configuration, or there's no need for the performance benefits, or they don't materialize.
Okay, now I think this next question, which has actually come up in about 6 different, slightly different varieties, but all the same, which is, it sounds like everybody was pretty excited about the transition from spread to what you're calling the network transfer service, the new transfer service, which I promise you will work on the naming. Yes, as you said. What's your timeline? And let's be clear to the audience that this is not a flip switch. This is definitely a transition, but feel free to talk about that a little bit, Chuck.
Yeah, so this again is a progression that, if we want more technical detail on it, it's really a better developer lounge question than it is than here. But we have certain spread messages that have large payloads, and those would basically spend a lot of time on the spread ring. We can send those payloads around on the transfer service, and then they can get reconciled with the part that says what to do with them that comes over spread. So that offload helps a lot, and we'll be doing more of that. At some point, we expect that only the messages that need to be ordered, like membership and commit, really are the ones that have to go over spread. But the vast majority of the traffic in terms of payload bytes is not on spread. And so the system will scale a lot better, even though we still have it a little bit. And then there's interesting debate about what we'll do instead of spread when we're really done.
So it's definitely a journey that we're on.
Everything seems to be here, yes.
Yes, it is. Absolutely. So we are about out of time. Now, I will tell you, I'm going to ask you one last question that is showing and it's a little bit more tactical as well, but I do want to encourage you all to take advantage, as Chuck mentioned, of the Developers Lounge. The developers love to be challenged, and each day, today, tomorrow, and on Thursday morning East Coast timing, you can drop into any of the 5 Developers Lounge rooms with different topics, one of which will be chaired by Chuck, and I do enjoy seeing you challenge them. They enjoy that too, and we see who wins in terms of that. But here's your last question for this session, Chuck, and it's almost a consultative perspective, I think, on your part. Can multipart plan be significantly faster when I rewrite complex queries into multiple queries, materializing into temp tables? Now, I just read that question, but just to be clear, I have no idea what I just said.
I think I have a pretty good idea what the question means. I'm really glad that the last question wasn't what's your dog breed or something. I think you do have to go around and collect the whole set at the developer lounges. So, when we write these complex queries internally, they sort of do get broken down into pieces, right? Whenever you have a certain grouping operation, you run the part that inputs to that, and then you run the part that outputs to that. If you break those up into Vertica today, I can always go back to our little performance files of things we wish were better, and I can find you queries that breaking it up with just even insert select temp tables makes it faster, because of the way there's more resources assigned to things in the query plan, or because it lets us control how to do it in a certain way. So yes, multi-part plans will be even more efficient than that, because the way we store the temporary data in the temp relation is much better than a temp table. So definitely breaking queries up sometimes, you would think that should not help. It's kind of not something I like to hear, that people put in a lot of manual effort to make something run better. That's not where we ultimately want to be as developers. We want it to be magic and take that approach when it would automatically work. And so that's part of what you'll see us trying to balance in as we go forward with new versions. How do we know that it's absolutely going to be a performance win to split the plan up and then just do that for you?
All right. Well, that sounds like automation at its finest. So now we are at the top of the end of this session. And again, you can continue to quiz Chuck and all of our developers in the Developers Lounge. And remember, with this session, as well as when you drop into the Developers Lounge, you can earn points. Points means prizes. And most important to me, all of those points also count toward the contribution that Vertica will be making to Out of the Cage, which is a very important charity using analytics and technology to save dogs' lives. So Chuck, thank you for this session. And now I'm going to reveal the code for this session, which everybody can then enter into the Analyze to Win platform. And that code is, it's not showing on the screen yet, but I trust that it will, and there it is, Basset Hound. And yes, the theme for all of these are dogs. Basset Hound, remember it's B-A-S-S-E-T, that's one T, hound. Enter Basset Hound into the Analyze to Win platform. Now, in addition to entering this code, I want you to listen to a pretty cool message from one of our gold sponsors, Good Data. And as Chuck mentioned, we've been doing some really cool partnering, especially in the Kubernetes and containerization space with Good Data. So with that, I'm going to ask that the Good Data story be told a little bit. I hope you enjoy it, and I'll see you in the next sessions.
Do you want to make self-service analytics an inherent part of your software product? With Good Data, you will launch in just 8 weeks, serving hundreds or thousands of customers, with a return of $4 for every dollar invested.